spatial feature handling will be applied to get the attributes and the selection, and the temporal data is handling the future and the present and the past data. And in that feature extraction with the help of the convolution LSTM algorithm, long short-term memory, the previous history will be analyzed here, and use of the attention LSTM and the LSTM classification, we can classify the CKD and the non-CKD. And finally, with the help of the bidirectional LSTM, we can identify the stages, accurate value. So in this study, the automated stochastic deep radial basis algorithm has been used to identify the prediction level in a high accurate level. So the radial basis foundation RBF, it is a mathematical function which maps input data to a higher dimensional space, enabling efficient modeling of the complex relationship. So the deep architecture, the multiple layers of the RBF functions are stacked to learn the hierarchical representation of the input data. So the stochastic optimization, the randomization technique such as stochastic gradient descent are used to train the model for the future work. So initializing the convolution LSTM for the parameter for feature extraction. So process sequential data through the convolution LSTM layer and capturing the spatial and temporal patterns, and finally extracting the features from the hidden data. So the proposed system will give the evaluation matrix. It will give us the accuracy. So the ratio of the occurrence for which the prediction was accurate out of all the instances. It gives a general assessment of how the accurate model is. And it will recall the history of the patients, and it will give the precision of the positive instance that are realized, and the F measures the harmonic mean of recall and precision, and it prediction of the error. It predicts the absolute disparity between the actual and the projected condition of the chronic kidney disease progression. In the summary, the proposed method will have the combination of SDRB plus ResNet and BiLSTM demonstrates a significant improvement over existing method across various performance metrics. It consistently achieve lower FAR, false accept rate, and the false reject rate values, indicating its effectiveness in minimizing incorrect classification. The high PPV, the positive predictive value, and the non-positive predictive value reflects its ability to accurately predict the positive and the negative cases, essential for reliable CKD progression. So finally, the proposed method suggests more adept in handling the complexity of the CKD with the help of the SDRB, that is stochastic deep radial basis, and the ResNet and the BiLSTM. So the comprehensive approach to the CKD prediction has been achieved. So despite of a slightly increase of the computational time, the significant gain in prediction accuracy and reliability justify the proposed method used in clinical setting for early intervention and the personalized healthcare. So these algorithms are going to play a vital role to predict the CKD and its stages. Thank you.